Hello everyone and welcome back to the Proactive Learning YouTube channel. Today we're going to go through question 22 from the June 2019 higher tier GCSE maths paper, paper 3. So let's see what the question's asking us. So the diagram shows a circle with the center O. Then we have our diagram. Now we're told AB is the tangent to the circle at the point A, and the angle OBA is 30 degrees. Then we're also told the coordinates of point B and an unknown coordinate that we're labeling point P. And what we've been asked is to find the value of P. So, the first thing that we need to realize here is this is a question very specific on our knowledge of circles and possible circle theorems. So the first thing that we need to think about here is, what are we actually trying to find? We're trying to find what the value of P is. But the only place that P has been shown is for this point P. So in other words, we need to find out what the coordinate or the point P is, so then we can find out what the value of P is. So, what's one thing that we know when it comes to circles and tangents? So, one thing that we should have learned in class is when we talk about the radius of a circle, such as let's say from the center O to the point A, the radius is perpendicular to any tangent on the circle. So that's our first step, is knowing that the radius is perpendicular to the tangent. But how does that help us? The main reason why that helps us is because we've been given the angle here, 30 degrees. Now, what topic have we learned when it comes to angles, when it comes to finding the length of sides, and when it comes to right angle triangles? That's trigonometry, isn't it? So in other words, if we consider the right angle triangle that I will outline in yellow here, we can use trigonometry to find out the different lengths. In this case though, what is the length that we're actually interested in? So you might be wondering, why do we find out this length here? Would that help? So let's think about it, would it? So if we find out what that length is, does that help us find out what this point P is? And it doesn't, does it? So what's the other side that could be useful? It could be useful to find out what the actual length of the radius is, OA. But how could we find that out? So let's look back to how we find out sides using trigonometry. So first we have SOHCAHTOA, right? So sine is equal to the opposite over the hypotenuse, cos is equal to the adjacent over hypotenuse, and tan is equal to the opposite over the adjacent. Now here, we are trying to find the opposite, in other words, OA. But we don't really have any other information other than the angle. But has the question given us anything else which is useful? And the key thing that's really useful here is this coordinate here, B, which is 16, 0. So in other words, what the examiner has basically given us is the length of this red line here. They've told us what that length is, and that length is 16. But then if we look at this red length here, what is that in terms of our triangle? It's our hypotenuse, isn't it? So when we want to find the opposite and we're given the hypotenuse, which trig function should we use? So we have the hypotenuse and we want the opposite. That would be sine, wouldn't it? So in that case, we're going to use the sine function to find out the length of OA. So sine of, and in this case we have 30 as our degree, that is equal to our opposite, which we'll label OA, over our hypotenuse, which is 16. Now in this case, we don't want OA over 16, we want OA on its own. So in that case, we need to divide both sides. Apologies, not divide, we need to multiply both sides by 16. So if we multiply both sides by 16, what is OA equal to? It's equal to 16 lots of sine of 30, isn't it? So from here, because it's paper 3, we have a calculator we can use. So feel free to use your calculator and find out what sine of 30 is equal to. That is equal to 8. So 16 lots of sine of 30 is equal to 8. So OA is equal to 8. Now, even in a possible non-calculator paper, you know ways that you can find out or remember the value for sine of 30. So either way should be perfectly fine. If we look back at the center O here, if we want to go to the point P, in other words, we need to move a radius length to the edge, right? Because from the center of a circle to the edge of the circle, it's always a radius length. So in that case, let's redraw this here. So we have a center O, and we have the point P here, and we know this length here is the radius. Now remember, what was the radius? The radius is the same as the length OA, which is equal to 8. So we know this length here is 8. But what does the coordinate P tell us? It tells us we're moving 3P to the right, and we're moving P upwards. So from here, what we can now use is Pythagoras, can't we? So in this case, a squared plus b squared is equal to c squared. That's the equation for Pythagoras. And if we substitute everything in, we get p squared plus 3p, all of that squared, and all of that is equal to 8 squared. So then we have p squared plus 3p times by 3p is the same as 9p squared, and that is equal to 8 times 8, which is 64. Now from here, if we add 1 lot of p squared to 9 lots of p squared, we have 10p squared, and that is equal to 64. From here, how do we go from 10p squared to just p squared? We have to divide both sides by 10, don't we? So we get 6.4. And then from here, to find out what p is equal to the square root of 6.4. Now in this case, what you might be wondering is we need to put a plus or minus at the start, don't we? But the key thing here is, if p is moving to the right and moving up, we can just consider the positive outcome. So positive square root of 6.4. So what is the square root of 6.4? The square root of 6.4 is quite a large decimal, but we'll just write it in a simple form. So if we put that into our calculator, we get 4 root 10 over 5. By not rounding early on, we get to keep a nice number. So now, in this case, we've found out our value for p, haven't we? And it's 4 root 10 over 5. So is that our final answer? Now, if we have a look back at the question, we're told to give it to 1 decimal place. So in other words, this wouldn't be the right answer. So let's write it out as a decimal. So as a decimal, it's 2.529822128. And if we want to round it to 1 decimal place, that is the same as 2.5. So our final answer for p would be 2.5 to 1 decimal place. So that is the final answer. So with that, that is question 22 all done. Hopefully that answered any questions you guys had. Hopefully you guys feel more confident on finding the answer and the method we used. With that in mind, please like, comment, and subscribe. And that'll be it for today's video. See ya.